Good afternoon, it's Jeremy. It's Wednesday, August the 22nd. Today I want to talk about Splat, which is a propagation program that I've mentioned in previous videos, generally doing point-to-point analyses. But in this particular video, I'd like to talk about antenna patterns and how we can do a point-to-area or regional coverage. So in my blog post, I've got an example of a base station located at where I'm located, my QTH, and we're looking at what the analysis is with and without an antenna. So how do we handle an antenna? Well, here's the pattern of a Yagi antenna. It's got a 7 dBd gain. So there's the horizontal pattern and there's the vertical pattern. On the outside, it's relative to the maximum gain. So at the main lobe here, it's 0, and then it goes down to, let's say, minus 10, minus 20, minus 30, depending on what radial you are. And there's the vertical pattern. So how do we handle that in Splat? Well, we have to create two files, a .az file for the horizontal or azimuth, and a .el file for the elevation or the vertical plot here. What you do is you stick them in your working directory and you gave them the same name as the transmitter. So in my particular case, it's VE3 PKC.az and .el. So how do I get those files? Well, for the azimuth file, what I did is I used an Excel spreadsheet. Now the first entry is where your main lobe is. So in my particular case in the example, I'm pointing due east at 90, so that goes in there. And then you have an entry from 0 to 360, which is your relative gain. So what I did is off the antenna plot, I read off the relative gains in dB. So at 0, it's 0.0. At, let's say, 20 degrees, it was minus 0.5. Now these are relative gains in dB. So what you have to do is you have to convert that. For Splat, they want a voltage, your field voltage. So what you have to do is you have to convert that dB reading to a relative voltage. So what you do is you take the power of 10 and raise it to the dB over minus 20. So that'll give you that particular there. So for minus 0.5, then the relative voltage, field voltage, would be 0.94. So once I have those values, then what I do is I select column A and column D, and then I just paste it into a text file and give it the AZ extension. That's just a graph here, just to make sure there's nothing that sticks out there. Now for the EL file, so there's the EL file. Notice it's slightly different here. So the first entry here is your tilt. So not my particular case, the antenna is flat. It's not pointing up or down, so the tilt is 0. And that's the azimuth of the main beam here, which in this case is 90. So it's a little bit different construction from the AZ file. And then you have entries from minus 10, which would be a positive from the tilt up, and then down to 90, from minus 10 all the way to 0, and then up to plus 90. Again, what you do is you read in the values, the dB values, off the plot here. Okay, so you're reading off this blue line here. And then, again, what you do is you convert that to relative voltage. So it'll be, remember the voltage is 20 log, so it'll be 10 to the dB over 20 to give you this thing here. Then what you do is you copy and paste these into a text file. Again, I just checked them here on a graph. If we go to the blog post, here are the parameters of my base station. This is a hypothetical base station. I live in a very built-up area with lots of condos, so there's no way that you could put a base station here with all the high buildings. It just wouldn't work, but just for educational purposes here. So my transmit power is 50.1 dBm or 102 watts. There's the LRP file. For Splat, you need an LRP file, the long range rise parameters. So you put your ERP in down here. This is just a table of relative free space losses. And this is just basically what we've discussed. Down here is the Windows version of Splat, how you enter into it for regional analysis. And that's the plot without the antenna, without the AZ or the EL file. This is what it looks like. And then when you incorporate the AZ and the EL file, you can see there's a lot higher attenuation when you're off the main beam here. Okay, so that's the picture with and without the antenna. And then down here, I've got the same thing. I'm doing it with Splat in the Linux version in Ubuntu. It uses a slightly different model. It's not the Longley Rice, it's the ITWOM3 model. So there's the result without the antenna, and there's the result with the antenna. Again, you can see there's a lot more attenuation here off beam.